Hello, this is a video on finding distance in a coordinate plane. All right, so what we want to do here is to use a concept that we've had before, the Pythagorean theorem with right triangles, in order to help us figure out how you find the distance between 2 points in a coordinate plane. Now, if these two things were horizontal or vertical from each other, we could just simply count the distance. But this diagonal distance is a little bit more tricky because it's not exactly like I can just count from A to B or from B to A. But if you take a look for a second, I can actually use the distance here and here and create a right triangle, and we can use that Pythagorean theorem idea and find out what this is. So the idea is that this is a leg of the right triangle, and this is a leg of the right triangle, and this is a hypotenuse of that same right triangle. And Pythagorean theorem says the length of the leg squared plus the length of the other leg squared is equal to the length of the hypotenuse squared. So if I knew how long that distance was from B to this point where the right angle is, and I knew the distance from A to that point where the right angle is, I can use those two legs to help me figure out the hypotenuse. So that's actually what we're going to kind of do here. So, these couple of questions over here to the left kind of steer you to that. But the Pythagorean theorem and right triangles and triangulating distance, that idea is all what we're working with here. And the neat thing is, early radar and early tracking when ships and airplanes were they would triangulate to find distance. And, this is something that you're doing. It was seemingly, groundbreaking technology time ago, but like now it's a little bit, kind of a primitive thing, but we can do it, and we're going to do that today. All right, so let's do a couple of examples with that. So take a look right here at these two scenarios that I'm giving you, and I'm going to work through both of them with you. Now notice that I'm giving you actual coordinates for A and B, and we're going to take this first example 11 first. So if I go ahead and draw in and connect, and C is going to be where my right angle is going to be, and we're going to come up with the coordinates for that right now. All right, so notice that 2, 2, that point A, is on the same horizontal line. So it should have the same x value. So we know that it's I'm sorry, not its x value, the same y value because it's on the side there. I know that the y value is going to be the same as A, so that's going to be a 2. Now it's in a vertical line with B, so it should have the same x value. So it should be 6. Okay, so the coordinates of C are 6, 2. And if you need to pause your screen and look at that for a second to make sure you understand, totally makes sense. And now that I know what the coordinates of C are, I can actually count the distance from B to C and from A to C. So if I count down from B to C, 4 down to 2, that's going to be 2 units. Okay? And then if I count from A to the right to C, from 2 to 6, that's going to be 4 units. And those two sides make up the legs of this right triangle. And remember, I can use the legs to help me figure out what this hypotenuse, and I'll just call that x, is. Because leg squared plus leg squared equals the hypotenuse squared in a right triangle, in every single right triangle. And right now, and it doesn't matter which leg I want to go with first, so I'm just going to go with 4 squared plus 2 squared is equal to x squared, x being the hypotenuse. How did I know it was the hypotenuse? It's the longest side, and it's across from the right angle. All right, so now 4 squared is 16, 2 squared is 4, equals x squared. Combine like terms, and I get 20 is equal to x squared. Now, in order to get x, I need to unsquare it. So I'm going to have to take the square root of both sides. And now a couple of you are probably getting a little bit nervous because you're like, the square root of 20, that's not great. Well, I don't know what the square root of 20 is, but if you think about this in terms of, you can either find a decimal if that's not that big a deal for your teachers, or you can simplify this radical and break it down as best you can. You do know that 20 is 4 times 5, and you know what the square root of 4 is. That's 2. And I don't know what the square root of 5 is, so I can leave that in. So that would be simplest radical form. Or again, if your teacher is good with the decimals, you could just type that into your calculator very quickly. And the square root of 20 would be 4.47. So it really just depends on which answer is okay. But we just found the length of that third side, that hypotenuse, or the distance from A to B, and it was 4.47. And we could have never just counted that. That would have been way too difficult for us. But we found it using triangulation or Pythagorean theorem. All right, let's do it one more time with 12. And you can just, again, draw in here, come up with your coordinates on the same horizontal line, so it's got the same y value, and then on the same vertical line, so it's got the same x value, okay? If I'm counting down from 16 to 1, that's going to be 15, and if I'm counting from left to right, from 2 to 5, that's going to be 3. All right, I don't know what my hypotenuse is, and that's the distance that I'm looking for anyway. So 3 squared plus 15 squared, because those are my legs, should be equal to whatever the hypotenuse squared is. Don't forget to square these things before you start adding them together. That's going to be the number one mistake that gets made here. 3 squared is 9. 15 squared is 225 equals x squared. Add those together and you get 234 is equal to x squared. And I'm just going to grab my calculator on this one, take the square root of both sides just for time purposes here. The square root of 234 is 15.297 or 15.30. So this distance from A to B is 15.30. And so that's how we can triangulate distance and figure out the distance between 2 points that are not vertical or horizontal from each other, they're diagonal. Well, that thinking, convenient, but that thinking led to what's called the distance formula. So we use this idea of the Pythagorean theorem and the triangulating and the subtracting of the y values to get to what that side length is, and the subtracting of the x values to get to what this leg length is. And that helped us come up with what we call the distance formula. And you're going to be able to see that now. So take a second, pause your screen, and the distance formula is now in front of you, and you won't even need to triangulate any longer if you use the distance formula. So if you like the triangulation method, keep doing it. It's wonderful. Pythagorean theorem is something you're comfortable with, but the distance formula is something that was discovered over time and time and time again doing these triangulation problems, and we found out, wait a second, the difference between the y's and the difference between the x's squared, when you add them together and then take the square root, that's what's giving us that distance. So essentially, it's just doing all of the work with finding the side lengths, squaring them, adding them together, and then taking the square root, all the steps of that solving equation, and that's how we solve it. So the distance formula can help you do that. So let me just show you how this is going to work. So if I take this example here, 2, -3, and 12, 14, and I want to find the distance between them, notice that I don't even have a graph where I'm looking at what they look like. I don't know what they look like, but it doesn't matter. This will be my x1, this will be my y1, this will be my x2, and this will be my y2. And I'm simply going to use this formula to help me. Okay, so the distance between these two, which is also written as the square root of the difference in the x's, which would be 12 minus 2, and I'm going to square that, don't forget to square it, plus the difference in the y's, which would be 14 minus a -3, don't forget your negative signs, and don't forget to square it. And now I'm just going to simplify and work my way from the inside out. 12 minus 2 is 10. I still need to square it. 14 minus a -3 is 17, and I still need to square that. So here we go. 10 squared is 100, and 17 squared is 289. So if I add those together, I get 389. Grab your calculator, take the square root of 389, and I just found out that the distance between these 2 points is 19.72 13.2 units. And there we go. Notice that I didn't even graph these points or draw in a triangle. I could use all of those principles right here by having this distance formula. Okay. And you can see the little note that I left you there about memorizing formulas. But if you do these a lot and you do a lot of practice, I think that you're going to be able to find this very user friendly. Okay. So one more example for you before I let you go. We'll do number 16 because it's got a decimal in it. Some of us get a little complicated and confused with that. So we're going to call this x1 and y1. We'll call this x2 and y2. All right, and again, our distance formula, x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Okay, so now my distance is going to be negative 2 minus 11 squared plus 0 minus 3.5 squared. Negative 2 minus 11 is negative 13. Still need to square it. 0 minus 3.5 is negative 3.5. Still need to square it. Okay. Negative 13 squared. Remember, negative 13 squared is negative 13 times negative 13. That should be a positive number. 169. And then negative 3.5 squared is 12.25. Again, a negative times a negative is a positive. 12.25. Add those together. You get 181.25. Still need to take the square root of it. And you get 13.46 units. And again, that's without drawing or graphing at all. Okay, practice with this. Use either the triangulation method or the distance formula. And good luck.